Hi guys, and welcome to this tutorial on algebraic fractions. Basically, algebraic fractions look mean, but as long as you remember the golden rule of simplifying fractions, they aren't bad at all. The most important thing to always remember is you may only simplify fractions when you have one term divided by one term. Very shortly, I'll show you what I mean, but every single time you're tempted to start cancelling things, as we say, and simplifying fractions, I want you to ask yourself, do I have one term over one term? If the answer is no, then you may not start cancelling. The question is, though, how do we get to one term? What happens if I have 3 different terms? What happens if I have 4 different terms? How do I get to one term? And this is why we learned the tool of factorizing. If you have 3, 2, or even more terms, the way to get them to your algebra expression to only be one term is to factorize. Then you may cancel as much as you like. So let's have a look at our first example. Our first example, what I find that people most want to do is they want to start cancelling immediately. So exactly as I said, people want to start, oh, wonderful, a squared divided by a is a, and b squared divided by b is b, and 10 and 25, they're both divisible by 5. And absolutely not. That's exactly the biggest mistake of simplifying fractions, where people cancel without realizing that there are 2 terms on top and 2 terms on the bottom, which means you may not start cancelling. We have to get it to one term over one term, which means we need to factorize. Now let's quickly briefly recap. With factorizing, we always check for a highest common factor. If there is a highest common factor, we still need to check maybe we can do something else. As well as the fact that if there isn't a highest common factor, we have to check something else. So we always check. Now, this isn't a rule, but it's a guideline. I check how many terms do I have. If I have 2 terms, the possibility is it could be a difference of 2 squares. Now, you don't only get difference of 2 squares with 2 terms, but it's very common. If it's 3 terms, it is possibly and most likely a trinomial pattern. And then the last thing is, if it's 4 terms, in all likelihood, I should use grouping. Now, these aren't rules that work every single time, but they help me a lot to figure out what pattern I should be looking for with factorizing. So we always check for our highest common factor first. So let's look at the top. Is there a highest common factor? No, there isn't. How many terms is it? We've already said it's 2 terms. So is it the difference of 2 squares? And it is, because a times itself will give me a squared, and 5 times itself will give me 25, and b times itself will give me b squared. And we remember that one's a bracket, one bracket's a plus, and one bracket's a minus. Does it matter which order I put that in, whether I put the minus first and then the plus? Absolutely not, because these 2 brackets are being multiplied together, and as we've discussed before, multiplication is commutative, as in you can swap the order around. Right, let's have a look at the bottom. Go back to my factorizing. Step number 1, is there a highest common factor? Yes, there is. Now, this is where you ask yourself, do I take out a highest common factor of -2 or +2? Because you can always take out a negative or a positive highest common factor. It just depends. Now, generally, if this is -2a and this is -10b, I would take out a negative. It's just generally what I do. But there's nothing wrong with taking out a positive and then figuring out that that wasn't helpful. I'm going to take out a -2 because I can see why it's going to work better. Because -2 times a and -2 times +5b will give me -10b. Now, the reason why I knew I wanted to take out this negative is the whole aim of this was to get a common bracket at the top and the bottom, which means I could cancel. If I hadn't taken out a negative, I wouldn't have got that common bracket to cancel. Now, just remember with brackets, you may not cancel individual things in brackets. With brackets, it's all or nothing. You either cancel the whole bracket or you may not cancel it at all. So I'm left with a minus 5b over -2. Now I can leave this bracket around this a minus 5b, or I don't have to have it. It's not changing the meaning of my question, and there's no more ways that I could simplify that fraction. So golden rule, one term over one term, then I may start cancelling. Because these were two brackets multiplied together, it was now one term. Because this was a factor times a bracket, it was one term. Then I may start cancelling. Let's have a look at another example. Right, this is also just a simple fraction that we need to simplify, which means immediately I ask myself, is it one term over one term? Well, no, because the top is 4 terms and the bottom's 2 terms, which means I may only cancel things as soon as I've got one term over one term, which leads me to factorizing. Now, if I look at the top, I see 4 terms. I should always check for highest common factor first, but there's nothing that's common to all 4 of those. Now, because there's 4 terms, I'm thinking grouping. Now, what 2 terms have something in common? Those 2 have something in common, and those 2 have something in common. It might be the way to go, it might not. We might need to go and group them differently. But that looks promising, which means I'm going to rearrange it so they're next to each other. So I'm going to have the ax plus x next to each other, and the minus b minus ab next to each other, because then I can factorize more easily. And if I look at the bottom, I can start factorizing immediately with the bottom. Common factor is a, definitely, and there's an x that's common, which means I'm left with x minus b. Now, always check your factorizing. So let's quickly check. Ax squared, yes, minus abx, absolutely. Now, let's go factorize the top. I'm going to take out a common factor of x with the first term, with the first 2 terms, and I get a plus 1. And I'm going to take out a common factor of, now here's the question again, do I take out a negative b or do I take out a positive b? Well, both of them are negative, which means maybe I should take out a negative b. Let me check. If negative b doesn't produce something interesting and useful, then you can change it and take out a positive b. So if I take out a negative b, I'm left with 1 plus a. So this is minus b minus ab, absolutely. So my negative b did work out usefully. Why do I say that? Let me write in my denominator. Why I say that is, what I've noticed is here I have an a plus 1, and here I have a 1 plus a. Now with grouping, the whole idea is to build a common bracket so you can take it out. Now, some people look at 1 plus a and a plus 1 and say they're not identical, but addition is commutative, which means 1 plus a is exactly the same thing as a plus 1. I don't even have to write it down on the page and swap it around, in the next step. You are allowed to assume that obviously that those 2 are exactly the same bracket, which means if I want to on my next line, I can take out a common bracket of a plus 1 without showing the swapping around, because it's obviously the same thing. Which means I now have, check, is it one term over one term? Bracket times bracket is one term. Ax times a bracket is one term, which means if you have identical brackets, you may now cancel. And I do have an identical bracket, x minus b and x minus b, would leave me with a plus 1 over ax. Now, most people are tempted now to go, wonderful, the a and the a cancel, but I can't. It's not one term over one term. If I write it with a bracket like that, it is one term over one term then. But in that case, you either cancel the entire a plus 1, or you may not individually go into a bracket. It's the whole bracket or nothing, which means that fraction is as simplified as it can be. Right, let's look at this guy. This one's a bit more complicated because it's a fraction times another fraction. Well, not a problem. As long as I have one term over one term, I may start cancelling. So that is an algebraic expression which is 2 terms. That's an algebraic expression which is 2 terms. That's an algebraic expression which is 3 terms. And that algebraic expression is 2 terms, which means each of those algebraic expressions I need to factorize, and then I may simplify. So let's start at the top. Ax minus 3a. Highest common factor first, and there is a highest common factor of a. Leaves me with x minus 3. Always check. Ax minus 3a. Absolutely. Right, next. Divided by x squared minus 4. Now, hopefully you've practiced so much that you see x squared minus 4, and immediately you know that's a difference of 2 squares, x minus 2, x plus 2. Should check x squared, yes, plus 2x minus 2x. Nothing. That's why the two brackets had to have different signs. And then minus 2 times positive 2 will give me minus 4, so that's correct. Next one is x squared minus 2x. Well, there's definitely a common factor of x. X minus 2, check. X squared minus 2x, yep. And last one is 2x squared minus 5x minus 3. Now that seems quite complicated, and it's trinomial, which most of us don't like. Now, trinomials always come from two brackets, and it's pretty obvious if you have 2x squared that it has to be 2x and x. Now, this isn't a bad one. It isn't too difficult because this last number is 3, which means these two numbers multiplied together have to give us 3. Now, the only way I can do that is 1 times 3. So somehow I need to figure out, must the 1 be here and the 3 here, or the other way around? Well, either you can try that way and then try the other way around, or we can think about this more intelligently. We've got 2 and 1 as these two coefficients, and now we're trying to figure out 3 and 1. And somehow when we multiply these two numbers together and these two numbers together and we add them up, we need to get minus 5. So if I did 2 times 3, I could get 6. And if I did 1 times 1, I could get 1. Can I somehow add those together to get 5? Yes, I can. Now I want minus 5. So that means I want minus 6 plus 1, which means my 2 needs to be multiplied by minus 3. There we go. And my positive 1 needs to be multiplied by 1. Now, I always just check, because maybe I've put it the wrong way around, maybe my signs are wrong. I can always go and change it if I'm wrong. 2x squared, yes, that's right. Minus 6x plus an x would give me minus 5x. So you can scribble on your exam paper and figure it out that that's right, and then minus 3. So yes, I'm right. Now, all this working out, you're welcome to do in pencil on the side of your page, or you can scribble, and I always check on my exam paper. I always scribble stuff down when I'm checking. Now, do I have one term over one term? Because if I do, I can start cancelling. Well, I've got a times a bracket times x times a bracket. That means the whole of that top is one term. At the bottom, I've got a bracket times a bracket times a bracket times a bracket. So the bottom is one term, which means if I have brackets which are identical on the top and the bottom, x minus 2, I may cancel. X minus 3, I may cancel. So what am I left with? I'm left with a and x. So a times x I could write as ax. The bottom I'm left with x plus 2 and 2x plus 1. Is there anything more I can cancel? Again, we might be tempted to say, oh, x and x. No. It's either the whole bracket or it's nothing. So I cannot cancel those x's. Now, should I multiply out this denominator? Should I multiply out a binomial times a binomial? You're not going to achieve anything by doing that. So there's no reason to multiply out the denominator. That is a perfectly acceptable way to leave your answer. That's as simplified as the question gets. Now, our last example is quite a complicated one, so I've left it for the next tutorial. So make sure you move on to the next video to finish example 4 and to get the homework exercise.